Question 5. This question is about some group 7 compounds. Solid sodium chloride reacts with concentrated sulfuric acid. Common salt sodium chloride, sulfuric acid, you get white steamy fumes of HCl. If you remember that, you'll probably be able to do the equation then, because sodium chloride, NaCl, sulfuric acid, white steamy fumes of HCl, and then you've just got to work out what's left over. I've got an Na, I've got one of the H's, one H is there, there's two here, so I've got an H and I've got an SO4, sodium hydrogen sulfate. Let's have a look at the role of the sulfuric acid. Well, it's added an H to the Cl. Something that adds H pluses to a compound that's an H plus donor is an acid. Let's just check out it's not an oxidized agent, that the Cl is in -1 oxidation state because Na is in group 1 and +1 oxidation state, loses 1 electron. So the Cl is in -1 oxidation state. Hydrogen's in +1 as well. Group 1 of the periodic table loses 1 electron, +1. The Cl's in -1 there as well. So it's a -1 in both of those. So the sulfuric acid is not actually an oxidizing agent. It's just adding H pluses. It's an acid. It's an H plus donor. Fumes of sulfur dioxide are formed when sodium bromide reacts with concentrated sulfuric acid. What's the equation? So I know I'm making sulfuric acid with sodium bromide. Well, what sodium bromide does is it does this equation, NaBr instead of Cl, NaBr sulfuric acid H2SO4 makes HBr and NaHSO4, but it reacts again and it forms bromine. So sodium bromide and concentrated sulfuric acid, it then goes on to make bromine and it makes this sulfur dioxide a choking gas. What else is made? Well, I've got H's and O's, so there's a good chance that I'll make water, and what have I got left over? I've got NA's and SO4's, sodium sulfate. How do I know sodium sulfate's Na2SO4? Well, think about sulfuric acid. You know sulfuric acid is H2SO4. I've written that formula so many times. H is in +1 oxidation state. It's in group 1, loses 1 electron from its outer shell, +1 oxidation state. And so if it's H2SO4, why do I need 2 + 1s? It must be because the SO4 is in 2- oxidation state, 2 + 1s and a 2-. So this is 2-, and sodium's in group 1 as well, 1 plus ions loses 1 electron, so 2 1+ to balance out the 2- here, Na2SO4. How am I going to balance that? Well, I've got 2 Brs and 2 Nas, so I'm going to need 2 in front of the NaBr. I haven't got enough O's on the left-hand side. I've got 4, 5, 6, 7 on the right-hand side, so I'm going to have to put a number in front of this. Let's try a 2. 4 H's now, a 2 in front of the H2O, and that balances the oxygens. 8 on this side, 2, 4, 6, 7, 8. Observation. I get this. Bromine is a brown gas. It dissolves in water to make an orange liquid, but it's a brown gas when it's on its own. I suppose it might dissolve to give a bit of an orange solution with the water, but it's a brown gas essentially. So brown gas for bromine. Role of the sulfuric acid. Br is in -1 oxidation state, because we've said sodium's in +1. Br is in -1 oxidation state. Bromine on its own, 0 oxidation state, no charge left over. So those are in 0 oxidation state. So it's gone from -1 up to 0. It's been oxidized of the oxidation state. It's gone up. So this must be causing that oxidation. It's an oxidizing agent. Give the oxidation states of chlorine, NaClO3. Well, the Na's are in +1, the oxygens are in group 6, so group 6 will gain 2 electrons, there'll be 2 minuses. 3 2- is a 6- and a +1, the Cl is in +5. +1 + 5 is 6, 3 2- are 6- to leave no charge left over. The Cl is in +5, Na is in +1, the Cl must be in -1 to leave no charge left over. So let's have a look at what's happened to the Cl2. It's a process called disproportionation, where disproportionation is where a compound like Cl2 is oxidized. It's been oxidized, it's gone from 0 oxidation state up to +5 when it's formed NaClO3, and disproportionation when it's been reduced as well. So it's been reduced 0 oxidation state down to -1 in NaCl. So it's been oxidized and reduced. And that forms the next part of the question. What's happened to the chlorine? Chlorine in oxidation state 0 is reduced to NaCl, gone down to oxidation state -1, and it's been oxidized to NaClO3. Disproportionation, that's called. So, solution Y now contains two different negative ions. I'm reacting it with silver nitrate. I'm getting a cream precipitate. Well, silver nitrate gives a white precipitate of silver chloride, a cream precipitate of silver bromide, I think I've just found D, and a yellow precipitate of silver iodide. My cream precipitate is silver bromide. I've got bromide ions in solution Y. So I've found D. I've got a compound E as well. Now the compound E seems to disappear, or at least form bubbles of gas, when I add nitric acid. So it reacts with acids to form a gas. A gas of carbon dioxide is a carbonate. So I've got some silver carbonate. I've got carbonate ions and Y reacting with silver to give compound E. Compound E is silver carbonate, and then that disappears, reacts with the nitric acid rather, and forms bubbles of gas F. How did I know that silver carbonate was Ag2CO3? Well, I know that Ag is in +1 oxidation state, Br is in -1 oxidation state, it's in group 7, gains 1 electron, so Ag is definitely in +1 oxidation state, and I know a carbonate ion is CO3 2-, so 2-, 2 1+, I need 2 Ags. Carbon dioxide ionic equation to form E, AgCO3, so I need 2 Ag pluses and a CO3 2- to make Ag2CO3. Equations show the conversion of D into G. What's happening here? D is my cream precipitate, my silver bromide, reacting with ammonia solution. Ammonia is NH3 and it's formed a colourless solution. What silver does is it can gain two ligands, two NH3 ligands. I know that it's plus because the ammonia ligands, amine ligands, formed from ammonia, no oxidation state, they're charged 0, so that is in +1 oxidation state, so there's a +1 left over because these are zeros. And I'm going to need two NH3s here to balance it up. I'm going to make Br, and the Br is going to be a minus, and that's going to balance out with the plus.